Hello, everyone. Welcome to another live episode of Visual Studio Toolbox. Happy Thanksgiving week if you're in the States. And if not, happy, oh my gosh, you can probably get more work done because your American coworkers are off stuffing themselves with stuffing. So I'm your host, Leslie Richardson. And in this episode, we are going to be talking all about Poly, which is a cool .NET resilience application library. And joining me today to talk about that is Martin Costello. Hey,
Hi
Martin.
everyone.
How are you doing?
I'm good, thank you. None of the Thanksgivingness happening over here though, because I'm based in the UK.
Yeah, darn. Yeah, well, I need to get better about trying to figure out how to send food to people because I'm into baking and I was gonna make like a pumpkin pie. I was thinking, I was like, how do I ship this to all my friends who live
Oh,
elsewhere?
baking's always welcome. Like we have
Night, right?
bake-offs every day,
Oh my gosh. Yep.
but we have to
Yeah.
wait until December for turkey. December is turkey time.
Nice. I like it. I mean, I'm not a huge turkey fan. I'm more of a ham person personally, but go either way. But great. So yeah, we're talking all about Poly today. But before we do, housekeeping thing. If you've got any questions about the Poly framework as we're talking about it, feel free to drop them in the comments and we will do our best to answer them. And that's all the housekeeping that we've got. So for now, Martin, would you like to tell us a little bit more about yourself and we can hop right in?
Sure. So I'm Martin Costello. I'm based in the UK. I'm a principal engineer at justeattakeaway.com. I'm also a Microsoft MVP for developer technologies, and I'm also one of the co-maintainers of Poly, the library we're going to talk about today.
Great. And you said you worked on, or you just used to be a regular Poly user prior to actually working on it, right?
That's right. I got invited to be help maintain Poly back in, I think it was 2020. It might have been 2021. It was definitely during the period which we won't speak of. But before that, I was just a user of Poly, a happy user, just plugged it into all of my apps. Well, maybe not all of them, but the majority of my apps where they do like important production level type things. And it just helped make them better and handle all those strange things that you never think of when you start writing an application. And then the real world comes at you real fast. And then suddenly you find all the weird edge cases.
Yep. That's really cool. I like the transition into now you're actually working on it and you can, any complaints you've ever had, you can now go and fix. So just starting from ground zero, can you tell us a little bit more about what actually is Poly?
Sure. So I'm sure as many application developers listening have experienced in the past, is like you have your application and it talks to another API, or it uses a third-party service, or it talks to a database, or maybe it does those things, but they're in the cloud, not on your local network. And then you have things like, DNS happens because it's always DNS, or network timeouts and all of those sort of things. And your users are using your application and suddenly something blips, something in the network goes, a third-party service goes down, there's a data center outage, you name it, all the possible things that could go wrong, like cat pulls out a network cable, who knows? And your application stops working, your users are unhappy, and there's not much you can do about it. Maybe your users will start pressing F5 really quickly and start reloading the page and then stressing your application out while it's broken because of whatever the underlying problem is. And then the problems start to compound. You get stressed. If you're on call for your application, it's production application, maybe your pager or your beeper goes off. And then suddenly that's interrupting your weekend or your evening, or maybe you're asleep. And it makes for lots of different classes of unhappy people, unhappy developers, unhappy users, maybe unhappy people who have to pay for all the extra scaling from the stress your application's under. And that's quite a well-known class of problems. And it all bundles together into like the umbrella term resiliency. So it's about you want your application to be resilient. If there's little blips here and there, you don't want to get, as the developer, you don't want to get bothered for, oh yeah, but retry and it will work again. It's fine. Or if suddenly I know, Black Friday happens and that marketing campaign goes really well, and suddenly there's too much traffic for what you've designed for, and you don't know what to do. You don't want to get bothered about that stuff, and you don't want to have your business impacted. If your users not being able to use your application means you're losing money, you don't want that to happen. You just want everything to tick over. And even if there are problems, in most cases, you want them to just go away, not be noticed, just be little ripples in the pond. And that's where Poly comes in. Poly is a resiliency library, and at its core, it's built now in version 8. It's built around what's called a resiliency pipeline. And you can compose that pipeline from multiple what we call strategies. And strategies handle different failure error modes, failure cases. So what if something's too slow? What if something fails and you want to try it again? What if too many things are happening right now? What if things are just being a bit flaky? You want to hedge your bets. And we have lots of different strategies built into Poly. And there's also a community of external ones that do different types of strategies. Not all of those are currently integrated into the latest version of Poly, but the plan is they will be over time. So there's another type of library which is currently separate to Poly, and is being integrated inside the core of Poly at the moment, and it'll be in the next release. It's called Simi, which is a set of extensions which is related to the term chaos engineering. I don't know if you've heard of chaos engineering, but that's
not. That kind of sounds amazing.
The idea behind that is it's like you deploy your application to production, and you've gone, yep, I battle tested this. It's fine. It's bulletproof. And then you let a monkey into the data center and let it just start pulling out cables, kicking over servers, and whatever have you. And then you see if the application really actually survives the monkey being let loose in the data center. But we don't really want a monkey let loose in the data center. It's probably going to be quite messy and expensive.
Yeah, probably not great.
So the Simi library, which we're in the middle of integrating into the next release of Poly, does that for you. It will just randomly break things. Whereas Poly is there to sort of be the safety net when things break. Simi is there to create the chaos. And then you configure that. I'm not going to go into the depths of Simi, the stuff I'm going to show today. But it's kind of, they're like, handle problems, cause problems to check you can handle them.
Awesome. And also chaos engineering sounds really cool. If I ever change my job, I'd want to be able to write chaos engineering on my next resume. That'd be pretty sweet.
Yeah, I've never really done it in anger myself, because I always feel like you have to be at a very high level of engineering maturity to put that into your production environment, because that's when all the business people who pay the bills start to worry. You're going to intentionally break production. Yeah. But show it still works.
Yep, no pressure.
There's a lot of trust in letting someone do that.
Yeah, but that makes sense. Resilience is super important, especially once your app is out in the world in production and stuff, I can imagine. So yeah, let's talk about how Poly can make that easy.
Sure. So if we just go to, there we go. So this is just the GitHub repository for Poly. It's easy to find, but it's app-vnext/Poly. And here's our README here. I'm not going to read the README out to you. That would be dull. But we have a number of packages that have different purposes. So poly.core is our new main assembly that contains all of the goodies that I'm going to show you later. And then we have an extensions library that builds on top of it. So it's easy to plug Poly into your dependency injection container. And then we also have a package that builds on top of the rate limiting support that was added in ASP.NET Core 7. So we can just build that into it and sort of take two things and put them together rather than try and reinvent the wheel and do rate limiting ourselves. And then we also have a package that can help you test that you've configured Poly the way you think you've configured it. Because we do get that sometimes. We get issues in GitHub and it's just like, it's not working. It's not doing the right thing. It's like you didn't turn it on properly. Oh. Oops.
Or it's like, did you just restart your computer?
Yeah, almost that level of thing.
Yeah.
It's like you're convinced it's a really in-depth technical problem and it's a bug. And it's like, oh no, I just forgot to set a Boolean, or I forgot to set a number to greater than 0 or something like that.
Like, all right, I'm just gonna crawl in a hole now. No worries.
We've all done it.
Yep, we've all been there.
So we have a whole documentation site, which I'll pull over in a second. And we've got some quick start code snippets here for how you can start using Poly. And we also have like an overview here of the different types of policies that I mentioned. I'm going to keep calling them policies. They used to be called policies in Poly. It's kind of related to the name, but we call them resilient strategies now because of refactoring.
I'm team policies. How dare you get rid of a great pun like that? It's terrible.
So like we have retry policies. So it's like, well, it didn't work just then. Maybe if I try it again, it'll work. Then we also have another family, which is called circuit breaker. So the idea behind a circuit breaker is, I don't know, your database server, something's gone wrong with it. It's not responding, it's timing out. You want to give it a bit of space to breathe, because if all your users start pressing F5, load the page, load the page, load the page, a stressed database isn't going to be less stressed by you asking it to do even more work. So the idea behind a circuit breaker is it's similar to in electronics, is you break the circuit and that creates a short circuit. So now all the users' calls are still failing because they can't get to the database, but the database itself isn't being contacted. So if it's like a temporary problem, then the database is given that breathing space to recover and come back up. And Poly will periodically like try and let a little traffic back through to see if it's come back. And then if it has, things will start working again without any manual intervention. Then we also have fallback policies, which is just, well, if you can't get the answer from where you're supposed to get the answer from, what should I do instead? So a good example of that is, say you've got a social media website and everyone has a profile picture. And for whatever reason, you have to go off to the cloud to get that profile picture every time. And then wherever you keep your pictures goes down. In that scenario, then you could create a fallback that just says, here's a placeholder image, just render that. So then your application keeps working even though your profile picture system is down, because you've got a placeholder to deal with it. You don't kill the whole website and break it for all your users just because you can't see their pretty faces or their cats or whatever their profile picture happens to be. I'm going to skip 2 and then come back to another one. We also have timeout. So within .NET, if you're doing asynchronous programming, you've got the concepts of like cancellation tokens, and you can wire them up. So you can say, don't take longer than 5, 10 seconds, whatever it happens to be. But sometimes people forget to do that, or they would rather just configure it in one place and have it automatically apply wherever for whatever their business logic reasons are. So we also have a timeout policy where you can configure that into your resilience pipeline. So you can just have it automatically never take more than a certain amount of time and cut things off if they take too long. Rate limiting, as I mentioned that earlier, that's built on top of the new rate limiting that came in ASP.NET Core 7. And the idea behind that is if you, an individual user, are doing something, then we probably don't want them to hog all our resources. Like the average well-behaved user, they'll click around your website, they'll do whatever they want, they'll get whatever it is they need to do done. Everyone's happy. But then every now and again, there's always that person who presses F5 too much, or is actually a bad actor and doesn't like your company and wants to take you down because of whatever beef they might have with your business model. So you can then use a rate limiter in that scenario to say that every individual user, account, IP address, however you want to shard your rate limits, you can set things up, say, no one's allowed to do more than 5 things a second, say.
I like that.
So if someone's pressing F5 too much, they basically get told to chill out a little bit, enhance your calm, come back in a minute, try again.
Nice.
And so we have a strategy that can deal with rate limiting. And also a common thing for HTTP services is they'll return a HTTP 429 response code if they are trying to rate limit you. And a thing that can often happen when you do HTTP 49 is you can get a HTTP header back from the remote service called retry after. And that's usually a period of time or a timestamp. So Poly also supports listening to that and then taking that into account so that it knows that you should retry when the other thing says it should be time to retry, rather than just using whatever you have locally as the way to do that. And then the last strategy I'm going to mention, which is brand new in Poly V8, is the hedging strategy. And the idea behind that is, say you have multiple servers and they're different distances away from you, so they take different amounts of times, but they all have different information in them. And you don't know which one has the answer, or you don't know which one is the quickest. What you can potentially do is hedge your bets, hence the name, and you can ask all of them at once. And then what Poly will do is it will take the first successful answer and give you that answer. So it's almost a bit like doing a survey or asking for a quorum of something. And then whoever responds fastest, that's the answer you get. So even if they disagree, you're taking the stance as the application developer. There's like, I just want the fastest one. But you can also configure it in a way where it will just progressively ask different people if you don't get answers. So I could ask you an answer for a question, and then if you don't give me the answer back in, say, 2 seconds, which is far too quick for a human, then I'll just ask someone else, and I'll just ask someone else, and I'll just keep asking all the people I have available until I get the answer. And then I'll return that to the user. So that's what our hedging policy is for. And then Poly, with the resilience pipelines, that you should compose these together. So you can do, I want to do retries, but I don't want any requests to the user to take more than this long. And if things get stressed, then I want you to circuit break and protect me. But I don't want anyone to do more than these many requests per minute. And then you compose them all together. And then that sort of magnifies up the resilience and makes your application even tougher. And the thing that Poly helps with as well is typically if you start small with something, then the failure modes are infrequent. But say your business gets really successful and then you start to take off and you start to scale out and you go to the cloud and you have more and more infrastructure, you get to the point where there's like an old adage that like once you move to the cloud, then the failure is certain. It's just when is it going to happen? That's the bit. When is it going to fail? Not if it fails. So being able to easily plug resilience into your application right from the start or near the start. I mean, you've got to get your app out to your users first, demonstrate the value and start making that revenue. But once you've done that, plugging the resilience in early means that as you scale, you don't necessarily have to worry about at least like the simple failure modes. Like at very high scale, then you're probably you want to start tweaking the dials and stuff.
That makes sense. So best to start early with implementing the resiliency instead of waiting till the last minute.
Yeah. And then I'll just show this now before I get into some code.
Mm-hmm.
So if you've not used Poly or you've used Poly V7 and not Poly V8, and you like what you hear we talk about, and you want to research adopting this, then we have a huge library, maybe not the right word, library of documentation in our polydocs.org website, which was new for this release. And we had lots of help from the open source community in building these documentation pages out. We've still got more to do. It's nearly always the way that the documentation lags the implementation. We've still got more to document, but there's lots of content in here about how Poly works, the problems it solves, how to use the individual strategies, how to migrate from Poly V7 to V8, and other concepts like chaos engineering that you can read about and see what they are.
Awesome. Cool. So is it demo time? We're going to talk about how we plug this in. Awesome.
So now we're going to go to Visual Studio and the demo gods. The live demo gods.
Yep. Oh my God, please. Already praying to him.
So what I've opened here is we use, I apologize to the person who maintains it because I've forgotten the name right now. We use a great tool that you can find the name of in the repo afterwards, where we write code snippets that actually compile, so we can check that they work. Well, we don't test them, but we know they compile.
Great.
So when people do copy paste, you won't get squiggles from lots of compiler warnings. But those then get put into our documentation site. So I'm opening the raw snippets that go into our documentation. And I'm just going to go through a few of those and show the sort of the APIs you use to build things up. So this is our elevator pitch code snippet. This is the quick start. This just demonstrates what Poly does. So I've got a cancellation token here that says nothing should take more than 20 seconds. And the first thing I'm going to do is I'm going to create myself a resilient pipeline builder. So that's the primitive which we will use to configure what we want our resilience pipeline to do. And then what we do first is we add a retry strategy. So that's going to do our if it fails, try again, try again, try again. And this is using the default options, which is the point where I have to click through and remember what they are. But the idea is, out of the box, we want it to try and do something sensible and useful for you, because previous releases of Poly, you had to know in advance what you wanted it to do. Whereas what we're trying to achieve with this release is that if you want the bare bones, sensible default way of making your application more resilient, you just plug it in a few lines of code and you're off to the races.
Awesome.
And then if you want the customization, you can add that later to tweak things and make things more specific.
Yeah. So what do you get in that basic package? So if you just went with the default resilient strategy option. So
for a retry policy, by default, you get 3 retries. We have different kinds of back off. So the default is constant. So typically between the retries, there's also a pause, because you don't necessarily want to go try. So by default, it uses a constant back off. So what's the time? The default time is, tell you sense not to the rescue there, 2 seconds. So but by default, every 2 seconds, up to the limit of your retries, it will try again until it gets success. But yes, did not keep my tab. There we go. So that's the back off type for constant. But we also have, I navigated the wrong thing. We also have, constant is 2 seconds, 2 seconds, 2 seconds. Linear is it will add that much on every time. So if you wait 1 second, the second time it will wait 2 seconds. 3 seconds, 4 seconds, etc. And then we also have another one, which is exponential, which is related to the concept of exponential back off. So what that one will do is the delay will get longer and longer and longer with each retry, on the assumption that if it failed straight away and then it failed the second time, it's probably not going to succeed straight away again. It depends on your use cases, but that's what the exponential one is for. And then there's another thing I'll just mention, but isn't in the defaults, is we also have the concept of jitter. So what jitter is effectively randomness. So if you're doing a back off that's say 1 second, 2 seconds, 4 seconds, 8 seconds, and you've got hundreds of users on your website all at once, and then something breaks, so they all fail, you don't want them all to try again in 1 second and then it fail, and then all try again in 2 seconds and fail, because that's what's called the thundering herd problem. And then you get more and more traffic and it just gets out of control and everyone is sad.
Yeah.
So the idea of using jitter is that we put an element of randomness onto those retry periods. And what that does is it decorrelates the herd. So instead of everyone coming back at the same time, some of them come back and then a few more, then a few more, then, and they sort of fuzz out. So you don't get the the Ticketmaster problem. Taylor Swift tickets have gone on sale.
Oh my God, I was waiting for that. I had Ticketmaster in the back of my head just this entire episode so far. It's like I feel like Ticketmaster didn't have all these resiliency tools in place, or not as much as they should have.
I can't speak for the engineers at Ticketmaster. I'm sure they do a great job, but
yeah, absolutely.
Lots of Swifties get angry though, so
yeah,
there's something somewhere that needs a bit of tweaking.
Yeah, you don't want to make the Swifties mad.
So we've got our retries. So then after that, we had some timeouts. So even though for the sake of the demo, I've got my 20-second timeout here, what I'm telling Polly is that I want a 10-second timeout. So Polly is just going to add in a strategy here that under the covers, it's going to tweak some stuff so that a bit of the code we can get to in a second will actually have a 10-second timeout or a 20-second timeout. And then you could add in more strategies here for the sake of this bit of snippet. We've just got the two. And then when we're done, we call build. And build gives us a resilience pipeline. And that's the sort of the wrapper through which our business logic at one end will call the wrapper through the pipeline. And then the pipeline will call our other business logic, which is the bit we want to be resilient. So if we pop down to this bit here, I've just tweaked this code to make it fail. I'm not going to run this bit of code, but just to illustrate the point. So I've got my pipeline, and then I'm going to execute it. And I pass the cancellation token to it. So this is my 20-second cancellation token here. Mm-hmm. And then this is the Lambda method, which has got my business logic in it, which Polly is going to call on my behalf to make it resilient. And the parameter here is another cancellation token. So this cancellation token is the one that would have been tweaked by Polly to take our timeout policy into account. So it's linked to our original cancellation token, but is effectively now a 10-second timeout, not a 20-second timeout. So if this bit of code then used that cancellation token, it would observe the 10-second timeout policy rather than the 20-second timeout policy it originally had. And then just to show the point here, so this bit of custom logic, which is what we're doing with Polly, is it's just going to fail if a random number between 0 and 10 is divisible by 2. And that's all that would do, really. There's lots of different ways to execute the pipeline. It also supports synchronous code. So if you're doing something that's not asynchronous, you don't have to do any horrible sync over async to try and make things work. It also has a synchronous model, so you don't have to worry about it, and Polly will do the right thing for you. And it also supports, which isn't shown here, like you can pass state through to it, so you can avoid things like closures. So if I deleted the static keyword there, this would like be allocating a closure, sort of compiler mechanics to sort of make variables that I might have outside this scope work inside the scope. But that typically means that you need to allocate more objects and use more memory. And one of the design goals of Poly V8 was to try and reduce as much overhead that Poly introduces to your application as much as we can. So in many cases, if you follow the sort of the recommendations in our documentation, the overhead of adding Poly to your application should be 0 bytes. It shouldn't add any extra memory allocations on top of your application. There's awesome. A few scenarios where it does, but it's like tiny.
Cool. So pre V8, was that not the case? That 0 memory?
So what happened? Well, with Poly V7, the API sort of evolved organically, reached a point, and it was kind of stable, and there was not much work happening on it. And then some of the internal teams at Microsoft who were using Poly, I think with the 2020 boom in online services and things like Zoom, Teams, meant that they had a lot more infrastructure running, and they didn't necessarily want to have the proportional increase in cost to go with that. So they were heavily focused on optimizing their applications that run all of that infrastructure in the background. And as part of their optimization efforts, they got to the point where the bottleneck was something that wasn't directly in their code base anymore. And the biggest item in their like flame graph of performance became Poly. So the not the .NET team, the Microsoft team who was working on those services, they reached out to Joel Hullen, who's the main boss of Poly. He's got all the admin rights and everything. They reached out to him, and then he contacted me and a few other people who were involved in Poly, and then we sort of had a conversation. It was like, we'd like to make Poly faster, but all the ways we can think of to make it faster involve significantly changing the API that Poly presents to its users. So to not create friction and not fork the ecosystem and create yet another thing, the Microsoft team worked with us on the Poly project to sort of evolve Poly to meet the performance goals they had in mind and make Poly better for everyone, not just for the team that maintains teams, and give something back to the community at the same time. But at the same time, we built all of this stuff well, we didn't build it in parallel. It exists in parallel with the previous API service of Poly. So if you're a current user of Poly, you can upgrade to version 8 and not make any code changes, and it will still work. You won't benefit from the performance gains because you have to migrate your code to the new API to realize those. But the old stuff is still there because we didn't want to just create this big ecosystem schism and gone, yeah, we've refactored a load of stuff and now it's broken everything. And if you want any new bug fixes or new features, you have to do all this development work.
Yeah. Makes sense. Cool. Well, it's nice to see that it doesn't have or require that much overhead in order to use, because then you have to be doing the whole pros and cons over, should I use Poly? Like, I need the resilience, but like at what price?
Yeah, and in the repository, I think it's in the perf folder, there's a whole ton of checked in benchmark results that Martin Tomka, who did a lot of the development work on Poly V8, has put into the repository. So if you are so inclined, you can go and look at those benchmarks and see the differences of the impact that the new API makes over the old API.
Awesome.
And then another feature that came with Poly V8 is we also have extensions that build into the service collection, which is the default dependency injection container in .NET. So what you can do is you can configure a whole bunch of resilience pipelines up front, and however they're configured. In this case, it's just the same as the code snip I showed you before. But you can give it a name or a key. The key doesn't have to be a string. It could be a URI. It could be a number. It could be any custom type. It's just, for the sake of simplicity, strings quite common as keys. So you set up all your DI, you add all your services, you do all the things your application needs to do, and then you get your service provider, and then the magic type, as it were, to get things out of dependency injection for Poly is this resilience pipeline provider. So I get my pipeline provider, and then I just call get pipeline with my key. So because I registered it as my pipeline, I get it back out as my pipeline, and then I have a pipeline. So the advantage here is if you've got lots of business logic that does lots of similar things, but for different reasons, like lots of different HTTP calls doing different things, but with different services for different purposes, but you want all of your HTTP calls to be resilient in the same way. Instead of having to scatter the code to set Poly up and do the right thing all over your application domain code, instead you can just inject the resilience pipeline provider into your classes and then just access the strategies and just go, I just know I need to use the strategy with this name. I don't know what it does. I just know I have to use it.
Yep. That's really handy. I was kind of worried about like how much reuse is there with using the pipeline across multiple classes and projects and things like that. So it's
And
nice to know that there's a lot of reusability.
The other thing we can do, which I'm not going to show today, is if you create a resilience pipeline builder, you can add nothing to it and call build, and you'll still get a resilience pipeline. So if you've got tests, then you can like test your application code without thinking, oh, how do I need to set up all the resilience for that code and then test all of that code as well? Because making the resiliency itself work is our problem. We need to maintain that. You shouldn't have to worry about that. You should just trust that as long as you told Poly how to be resilient, it will do it. So, but when you're doing your unit tests, you don't necessarily need to care about that. You just need to care that, oh, if I asked for user 52 from the database, I got user 52 from the database. Not that, and it didn't take longer than 10 seconds, and it rate limited it, and it did this, and it did this, etc. So that makes for more maintainable code as well. Absolutely. And testable.
Yep.
So those are the two main snippets that sort of they're the lift pitch, because I'm British, so we're not going to have an elevator pitch. We'll have a lift pitch. They're the lift pitch. But now I'm going to swap over to another instance of Visual Studio, which I just need to fire up, which will take a second. And in a different repository, which I'll just bring over while that does its thing, is we also have our Poly samples repository. And there's a whole bunch of example code in there of different ways you can use Poly. And the demos sort of build up from not using Poly to using Poly a lot. And there's a web server that comes with it that intentionally fails. And then that gives you sort of like an illustration, not looking at the code, but like the external effects of what Poly gives you if you add it into your application.
That's cool.
So let me just swing over our incredibly high design sample.
I love the logo, though. I think the logo is excellent.
I take zero credit for the logo. It's got nothing to do with me. It predates me. But it is a very good logo. I like how its feet are the L's.
Oh, I just noticed that. That's such a cute design. Oh, shout out to whoever did the logo. Great job. It's very cute.
Right. So, whoops. Live demo gremlins. So, let me check I started it up in the right profile. Yes, I did. Right. So there should be a HTTP server running under the hood. Yeah, I'm not going to show you this. I'll move this away in a second, but there's a web server running under the hood here. That's replying to what the demo is doing. Mm-hmm. So the first demo. So the things for viewers to draw their eyes to are this big white box here, and this big navy mauve. No, it's not mauve, is it? That thing. That bit over there, which is going to have stuff in it in a second. Cool. So if I start up the demo without Poly being used. So what's happened here is it's happily getting replies from the server, and then it starts to get rate limited. And then it works again because the rate limit window is expired, and then it gets rate limited again. Mm-hmm. So the user experience of this one user who's being rate limited here is it works, it doesn't, it works, it doesn't. And if you take a look at the counters on the right-hand side, so we've got like 40 requests just made, but only 20 of them have succeeded. And 24, 25 are failing because we have no resiliency and we're being rate limited. So we're having a poor user experience.
Yeah, that's not good.
So let's add in some retries. And then we run the demo again. So notice here, it's not printing to the console as quick a rate, and that's because Poly is pausing and retrying to see if there can be some success. So we're up to 12 requests at this point, but the success rate is getting nearer to 50% now because we're doing more retries now. But also notice there's no red ones.
Right.
So every request is succeeding at the rate that requests are happening here, but none of them are failing outright because Poly is retrying under the hood transparently to your application code or the demo application code. So the end user isn't actually seeing these yellow failure modes. They're all happening internally in the app. So the requests are taking longer to the end user because Poly is retrying under the hood, and more resources are being spent in total because we're doing retries to our API under the hood. But the end user isn't seeing a problem. They're just maybe noticing a little bit of lag.
Yep.
So
okay,
just
so it's
adding
not
some
information overload like the previous version.
Yes. So with just a retry policy, we've made things in this failure mode better for the user. If in different failure modes, maybe the database has fallen off the internet, then maybe this isn't quite the strategy you want because you'll just make things worse by trying more, harder and faster. But in this particular scenario of the rate limiting, you're sort of hiding the problem from the user. So let's stop that demo. So now let's add exponential backoff, which I mentioned earlier. So if I start the demo again, so notice this time it's still retrying, but it waited for, oh no, I made a small change to this earlier and I've changed the behavior. Oh, there we go. I got what I wanted. It didn't used to have jitter turned on and I turned jitter on, and that's changed the behavior of the demo to not what I was expecting. But you can see here, let me just stop it. So there was a retry here and it waited for 1.3 seconds. But then the next time it waited for 4 seconds. So that's the exponential backoff coming into play. It's not just going, wait a second, wait a second, wait a second. It's waiting longer. And the overall effect is still that all of the requests are getting back to the end user eventually. There's no red failure ones. But we're not using as many resources to deliver the same to the end user now, but we are making them wait longer, because if it fails on the first retry, we will wait longer until we do the second retry. So we're spending less server budget overall in terms of doing requests, but we're making the end user wait longer.
Great.
And let me do one more for good measure. Oh, let's put in a circuit breaker. So in this case, right, so the behavior's changed here. Let me just stop the demo and then I'll go through the logs. So everything was happy and fine to start with. And then we started to get rate limited. And then we got rate limited too much. So the circuit broke. And then we go red, because in this scenario, what we've opted to do is that if we retry too much and we overload the server and we break the circuit, then we just fail fast. So in this case, the end user is seeing a negative scenario, but in this scenario, the balance is that we want to protect the server.
Yeah.
So we don't keep adding retries on top of it because it might make things worse. And instead, we're just going, no, stop.
Well, you're ahead.
And then after a period of time, it tries again to see if it's come back. And it does. So the circuit closes again. And then we have success again. And then we start to get rate limited again. And then the circuit opens again. So if you were to leave this demo running indefinitely, it would just be going up, down, up, down, up, down. But in the scenario this is demonstrating, that's what we want it to do, because we don't want our server to catch on fire or explode or whatever it is that it does when it's getting too many requests.
Right. Awesome.
And then the final thing I'm going to show is as part of the collaboration we had with the Microsoft teams, is the .NET team built a whole bunch of libraries that extend .NET as part of the .NET 8 release. And two packages that are part of that suite of libraries are the Microsoft extensions Resilience libraries. And what these do is these build on top of Poly V8 to provide you with even more sensible defaults. So the team has like thought with all their experience of like cloud application, what's the most common 90 percentile way you should protect your app that's the most useful for the least amount of investment in changing your code base. So I'm going to show two quick sort of Git diffs of me putting this library into two applications of mine, because in these cases, they're sort of toy applications. So I'm not like got my business, how do I protect all our revenue brain on? It's just, how do I just make it a bit better? So in that case, I don't want to like massively dig in to, I'm just finding the link I want, massively dig into thinking about what to configure. I just want it to do something sensible. So in the case of HTTP client, if you're using HTTP client factory, then here we go. Just zoom this in. So the default for the Microsoft Extensions Resilience HTTP library is it gives you a rate limiter, a total request timeout, retries, a circuit breaker, and an attempt timeout. So every individual attempt can only take so long, but the total trying to retry and everything can only take so long as well. So if I plug that into an application, just zoom this a little bit. So this is a Git diff. Not all of the bits of the diff are relevant to this. So in the previous release of ASP.core, they had a Microsoft Extensions HTTP Poly package. That's now been superseded by the new Microsoft Extensions HTTP Resilience package. So I'm adding that into my application. This is a RC1, so it's 8.0.0 now. It's not pre-release. It's all gone out to the world. It's here. It's arrived. It's shipped. So actually, another interesting thing comes up. When I did this, I added 21 lines of code, and I deleted 69. So I've actually been able to remove code from my application and have it effectively do the same thing. So I deleted my custom Poly registration code, and then the magic line, add standard resilience handler. So I was already using HTTP Client Factory, but with this one line of code on all my registrations for HTTP clients coming out of DI, I can add standard resilience handler, and now I get all of those sensible defaults for free, effectively, by adding one package and one line of code, well, in this case, 3, adding that in, and then I get all of that for free. And then I can hack away and delete loads of extra code and like a whole class of extensions to configure Poly. And then
that's very satisfying.
And then one final example I've got. This is hand-rolled because there isn't currently an entity framework core version of the HTTP drop-in and how it works. But EF Core does have its own resiliency built in for different providers. But in this case, I'm just adding the resilience package. And then what I can do is I can create a custom execution strategy, which is a type built into EF Core for like having a strategy on executing database queries. And I can just hook Poly into it. And then I can make EF automatically use Poly to retry my database queries. So here I'm just like add resilience pipeline, and I just said, can you handle any exception that's a DB exception, invalid operation exception, or a timeout exception? And it'll retry my queries for me automatically.
Great.
And that was all of my code demos.
Woo! Yeah, I gotta say, it is very refreshing to be able to get to delete a bunch of code as you're adding in.
Yeah, it's you can sometimes get too carried away going, oh, I'm adding more stuff, I'm making everything better. But then it's like, but making it better by deleting code, that's sometimes quite rare. It's quite satisfying. Although it often scares people when they review your pull requests, and it's like thousands of lines changed. Like, what did you do? It's like, they're red. I've deleted them. It's fine.
Yeah, it's like, but this looks like a lot of like important initialization stuff. It's like, oh no, it's fine. Don't worry about it. Good stuff.
I just realized I've been talking almost nonstop for 55 minutes.
You did it. I know you were worried about hitting the hour, but yeah, you did a great job.
I feel bad in case there's questions though.
Yeah, I think people are into it though. We haven't gotten a lot of questions aside from my questions. We do have somebody in the chat who does like to spam the rate limiter, as you mentioned earlier. So I'd be lying if I wasn't one of those people sometimes when I'm frustrated too. So I apologize.
It's being a human chaos engineering factor.
Mm-hmm. So maybe we just hit F5, spam F5 more and more. It'll magically work after the 500th attempt.
It's got to work eventually.
Yeah, right. I'm optimistic. But great. So this is really cool. It seems like it's very easy to use Poly to get set up with being able to address both those human chaotic issues and also just the chaos that can happen behind the scenes, even if you didn't intend for it to happen that way. So cool. So for people to go learn more, I'm assuming they can go check out the Poly GitHub repo. That's a first good location, yes. Right?
So app-phoenix/poly, there'll be links in the description later. But yep. It's pretty easy to Google poly.net, bam. It should be the first result. And we also have our new documentation, which is all linked to in the README of the GitHub repository. Most of the documentation to get you started should all be there and like what you would expect. But there might be some topics we haven't got around to migrating to V8 yet. But as with any open source project, we're always open to issues, suggestions, contributions. We've had so many great contributions from the community to like build out our like in fact, having the documentation site, that was an idea from an external contributor. They just came along and went, hey, if you use docfx, you can build a whole website and it's better than your GitHub wiki. And we were like, sure, we'll take it.
Awesome. I like that person. Great suggestion. Sweet. That's it. Yeah, you do have a follow-up question response to rate limiting. So shouldn't a rate limiter be part of a firewall, or do the firewalls lack the info needed to do proper rate limiting?
So that's a great question. So as with a lot of things in software, it depends. No, but the serious answer is defense in depth is good. So your firewall or your your WAF, whatever technology you use, they're great for sort of the volumetric stuff. They're for the botnet that hates you. That's what they're for. They're to stop that sort of stuff. They're there to cut the traffic off when it's all going very wrong very quickly at levels you can't even comprehend or deal with. But where Poly comes in is where you can run that custom application code and do the things that make sense in your business domain. So the example I mentioned earlier was like the avatars for your social media app. Mm-hmm. It's like your firewall isn't going to be the place you should really put code, if you can, that's making decisions on what social media avatars to use if it can't find one for a very specific user. But you can do that in code. So if the request has made it through your volumetric protections in your firewall and it's got to your application, you shouldn't be worrying too much about, is this a botnet at that point? You should be just trying to deal with your business problem at hand of like, what do I do if I can't find an avatar for this user? That's when you go, well, just use the company logo instead, or whatever it happened to be. So yeah, it's like defense in depth is the thing I'd say. It's like Poly is just another way to help protect and make your application better. It isn't a competitor to like a fully featured firewall.
Gotcha. Good question. And yeah, that concludes the question. So yeah, if people want to go learn more, check out the repo, which is very easy to find. Can confirm. I just typed in poly.net and it was the first thing to appear. So at least if you're using Edge, that is what appears first.
SEO for the win.
Yeah, yep. And yeah, other than that, we'll place any additional resources that we have in the show notes, hopefully within the next couple days. And yeah, if people want to reach out to you, Martin, can they?
Sure. So I've got tons of repos on GitHub for things that are relevant to the GitHub specific stuff, but otherwise they can contact me on Twitter because I refuse to not call it Twitter. And
Right.
my handle at Twitter is Martin_Costello.
Awesome. Cool stuff. And if you're wondering, there's a lot of Martin Costellos I noticed on Twitter. So if you're looking for the right one, check out the thumbnail for this video. It's the exact same profile picture. So look for that one. I'm assuming you're not going to change your profile picture in the next couple of days.
No, that was a really good photo. I've been milking that for quite a while.
Awesome. I feel that's usually why I don't change mine anytime soon. Like, this photo is too good. Yeah. I suck at selfies, and yeah, we're just gonna.
Or I have my website, which is just, there's not much there, but martincostello.com would always link off to whatever the right thing that is me is. Awesome. I got the .com and I'm keeping it.
I love it. Yeah, when life gives you .com, gotta hold on to that. Great. Well, Martin, thank you so much for joining us. This has been really cool. I had no idea that there was a library like this that could help fix some of those resiliency and fault related issues. So that is a really nice tool to have, and it looks very easy to implement in practice too.
Thanks you for having me, Leslie. It's been a pleasure to sort of pitch things and try and evangelize it and get more people to make their applications better for hopefully minimal effort.
Yeah, awesome. So yeah, thank you everyone for watching. Hope you all have a great Thanksgiving or chill time of doing nothing or just a regular old week. And until next time, happy coding, y'all. So see you soon.
Bye.